Chapter 5 NCERT Class 12 Continuity and Differentiability. Chapter 5 Continuity and Differentiability. First, it will be continuity. Means continuity of the function. When a function is a continuous, that is called a continuity of the function. So whenever we plot in the graph, if the graph means if we draw the graph without lifting of the pen in this way, so that will be continuous. If there is a certain broken so this is a discontinuous because there is a so this is a discontinuous. So it is a function of f of x is equal to 1 if x less than equal to 0, means all the value of x less than equal to 0, it will be get 1, and if 2 if x is greater than 0, means when the value of x is greater than 0, this will this is the x equal greater than, means whenever x is greater than 0, that is 1, 3, 4, 5, 6, it will give the 2, and if x is less than equal to 0, means 0 as well as less than 1, that will give less than 0, it will give 0. So this is a discontinuous function. So this first definition of a continuous function. Definition 1, it's suppose f is a real value function on a subset of the real number, and let C be a point in the domain of this of f, then f is continuous at C. If when it will be continuous. Definition 1 means a function is said to be continuous at the point C. At point C, when a function is f(x), it will be limit x tends to C f of x if the limit of f(x) is equal to f of c. If these two are equal, that is a continuous of a function. This is the first definition. Second definition, if it is not satisfied, if the function limit of f(x) is not equal to f of c, then it is not a continuous. If it is satisfied, limit x tends to c, f of x is equal to f of c, then it will be continuous. This is the first definition. And another definition, we have two definition of continuity. A real value function f is said to be continuous if it is continuous at every point in the domain of f. If we have 2 or 3 domains in the f, then it have to be continuous in each and every point of the function, each and every point of a domain. A real function f is said to be continuous if it is continuous at every point in the domain of the x, domain of f. So here if we have the domain, means here in definition 1 we are going to take and only at point C. Here we are going to take at the 2 point at the end point, including at the end point. Continuous every point means including the end point. So definition 2. So it had to be limit x tends to a plus f of x is equal to f of a. Another is limit x tends to, now is another point b plus f of b minus another side will be f of b. If these two have to exist, and these two, if these two are equal, then it is a continuous. If these two is not, if these two are unequal, then it is not a continuous. And we have the algebraic continuity of a algebra of the continuous function. Algebra continuous function means if f and g are two suppose f and g be a two continuous function at a real number c, then f plus g is also continuous at c, f minus g is all continuous at x equal to c, f into z is continuous at c, f by z is continuous at c provided f of g does not equal to 0. Means if we have the two function f and g at that is continuous at c, then if we go for the addition will be continuous, the subtraction will also be continuous, the multiplication will also be continuous, and the division also will be continuous, along with the denominator cannot be 0. So now exercise 5.1. Exercise 5.1, prove that the function f of x is equal to 5x minus 3 is continuous at x equal to 0 and x equal to minus 3 and x equal to 5. We have to check it, is this function is continuous at x equal to 0, at x equal to 3 and at x equal to 5. So first, what is the function? The given function is fx equal to exercise 5.1 question number 1. Exercise 5.1 question number 1. fx, this is the function given how much 5x minus 3 unka at x equal to 0. What is the formula? First f of 0, let's find the f of 0. F of 0, instead of x place with a 0, 5 into 0 minus 3, so it is 0 minus 3, that is minus 3. Now limit x, what is the formula? Limit x tends to c, f of x is equal to f of c. This is the condition. F of c, so c is here x equal to 0. Now limit, we already got this, there is minus 3, we have to find this. So limit, we are going to find at x, so x tends to 0, f of fx. Now limit x tends to 0, what is the value of fx? That is 5x minus 3 equal to, instead of x it will be 0. So 5 into 0 minus 3, that is 0 minus 3, that is minus 3. Minus 3. So it is continuous, fx is continuous at x equal to 5. X equal to 0. fx is continuous at x equal to 0. Now find at x equal to minus 3. At x equal to minus 3. First f of minus 3 is equal to, the function will remain the same, that is 5 into minus 3 minus 3. 3 5s are minus 15 minus 3. 5 6 7 8, that is minus 18. Now limit x tends to, it is minus 3 f of x. Limit x tends to minus 3, function is 5x minus 3 is equal to 5 into minus 3, instead of x it will be minus 3 and minus 3. This is from this, minus 18, 3 5s are 15, minus 15 minus 3, that is 15 16 17 18, that is minus 18. So both are equal, so limit x tends to minus 3, f of x is equal to f of minus 3. Therefore fx is continuous at x equal to minus 3. Now we have to find at another point x equal to 5. Function remain the same. What is the function? That is given function is f of x is equal to 5x minus 3. 5x minus 3. At we are going to find x equal to 5, x equal to 5. We have to show limit x tends to 5, f of x is equal to f of 5. This is the target. First let's find the f of 5. So f of 5, instead of x it will be 5. So 5 into 5 minus 3. 5 5s are 25 minus 3. So it will give 22. Now let's find the limit x tends to 5, f of x. So it will be limit x tends to 5, f of x is 5x minus 3. Now instead of 5 it will be, instead of x it will be replaced by 5. So it will be 5 minus 3. 5 5 is 25 minus 3, that will give 22. So this and this are equal. Therefore fx is continuous. Fx is continuous at x equal to 5. Now question number 2. Question number 2, examine the continuity of the function fx equal to 2x square minus 1 at x equal to 3. We have to check it out, is it continuous at x equal to 3. Given function is f of x is equal to 2x square minus 1 at x equal to 3. So f of 3, 2 on 3 square minus 1, 2, 3 3 is 9 minus 1, 9 2 is 18 minus 1. So that is 17. Now let's find the limit x tends to 3, f of x is equal to limit x tends to 3, f of x 2x square minus 1. 2 instead of x it will be replaced by 3. 2 3 square minus 1. 2 3 3 is 9 minus 1. So that is 9 2 is 18 minus 1. That is equal to 17. These two are equal. Limit x tends to 3, f of x is equal to f of 3. Therefore fx is continuous at x equal to 3. Now question number 3. Examine the following function for the continuity. We have to check it, is it continuous or not. Here they did not, in previous question they have given a certain point, that this point check at this point. So either 2, either 3, either 5, at least they specifically mention to check the continuity at a certain point. But in question number 2 they did not mention, and in the question number 3 they did not mention any point. So it's not possible to check all the point, because in the real number there are lots of numbers. So it's not possible to check for each and every number and to find is it continuous or not. For that purpose we are going to take the certain point, that is as certain point at particular point, that is at C. So question number 1, question number 2, examine the following function to obey continuity, is it continuity or not. So this is f of x is equal to x minus 1. So it's clearly visible, it is a polynomial. Every polynomial is continuous function. So this one we can directly write it, but these two we have to solve it. So this will be directly continuous because it is a polynomial function. Question number 3, Roman number A, f of x is equal to x minus 5. This is a polynomial. It is a polynomial function. Polynomial function. Therefore, it is continuous. Every polynomial function is continuous. Every polynomial function is continuous for all the value of x. For all the value of x. Value of x. Question number B. F of x is equal to 1 divided by x minus 5. So add x equal to 5. So f of 5 is equal to 1, 5 minus 5. That is 1, 0, 5 minus 5, that is 0. 1 by 0, that is not defined. Not defined. Not defined. So it is not continuous at. So it's not continuous. It is not continuous at x equal to 5. So now we have to check in other point. Let's take the excluding 5. Let me check. Let us check. So at x equal to c. X equal to c. Suitable f of c will be 1 c minus 5. F of c will be 1 c minus 5. So limit x tends to c, f of x is equal to limit x tends to c, f of x will be 1 x minus 5. So it will be 1 by c minus 5. So these two are equal. This and this are equal. So limit x tends to c, f of x is equal to f of c. Since these two are equal, therefore it is continuous function. Continuous function. Now Roman number C. Roman number C, that is fx is equal to, it is given x square minus 25 and x plus 5. For any real number, x does not equal to, let's take c does not equal to minus 5, because if we take the minus 5, it will give 0 and it will give the infinity. So we cannot take that number. So at x equal to c. So f of c, it will be x square, instead of x it will be c square minus 25. 25 can be written as 5 square. So that is c plus 5. Now this is algebraic formula, that is a square minus b square. So a minus b and a plus b. So it will be c plus 5, and this will be eliminate. It's give only c minus 5. So now let's find the limit. Limit x tends to c, f of x. Limit x tends to c, the function is x square minus 25, that is x plus 5. It will be, instead of x, it will be c square minus 5 and c plus 5. 25 can, this is 25 can be 5 square, so it will be c minus 5, c plus 5 divided by c plus 5. So it will give c minus 5. So these two are equal. Limit x tends to c, f of x equal to f of c. Therefore it is continuous function. Continuous function. the f of x is equal to x minus 5. So at x equal to 5, so it will be f of 5 is equal to 5 minus 5. So that is equal to 0. At x equal to c, case 1, if c greater than 5, so limit x tends to c, f of x is equal to limit x tends to c, f of x, that is x minus 5, let's say c minus 5, modulus of c minus 5. So it gives the c minus 5. F of c, it will give, that is c minus 5, modulus c minus of 5, that is c minus 5. So it is, here is, these two are equal. Now for the case 2, c less than 5, limit x tends to c, f of x is equal to limit x tends to c, f of x, that is x minus 5. Instead of x minus 5, it will be x minus 5, that is c minus 5. It will give 5 minus c, that is equal to c minus 5. F of that is f of c is this one. Here also f of c will be remain the same. Therefore fx is continuous.